Hello everyone. In the last lecture, we learned about the different terminologies. We learned about the term machine learning. We learned about the term artificial intelligence. We got to know about deep learning. We also discussed one of the examples of handling and learning with the patient diabetes related data. In this lecture, we are going to cover some of the basic concepts. We will get into a little bit about data mining again. Then we are going to discuss how X and Y is related. What do we mean by input data? What do we mean by output data? We will use this example, the data related to housing prices prediction. And using this data set, we will understand how we implement data mining based operations. And lastly, we are going to discuss this modeling method. How are we using the models, how we are using those techniques, and what is the process of it. In the next lecture, we are going to talk about the steps to build ML based application, any steps. So these steps will be discussed in the next lecture. Starting with data mining. So if you read the definition, data mining can be defined as the process of discovering hidden patterns within large data sets by using different methods based on machine learning, statistics, and database technology. So you use a combination of techniques, you use a combination of sub disciplines of computer science, and then you operate it on a data set to find out patterns which are hidden, right? And if you integrate machine learning, statistics, database, and create a subfield, an interdisciplinary subfield of computer science, that subfield is called as data mining. We use it to transform the information, we use it to transform whatever data set we have. We will dig into it, we will use our techniques, we will find out our patterns, and step by step analyze that data. So sometimes we also call it as knowledge discovery in databases, because data mining is mostly used in the context of databases, large databases. In order to mine within data, you need lots of data, right? And the output will be your information. So the other name for this data mining can be knowledge discovery within databases. So just blankly try to imagine if I give you 100 databases, different databases, each like 2 GB in size. So you have 200 GBs of databases. How are you going to handle that data? How are you going to manage that data? How you are going to specify it, work it out into a particular structure? What pre-processing techniques you are going to apply? Which type of model you are going to apply? What kind of matrix you are going to use? What is the complexity of the questions which you want to ask with respect to that data set? What will be your procedure of finding out patterns? All of these come under the heading of data mining. So it will include data extraction, data cleaning, data processing, finding out patterns, finding out answers. Everything is under this one term. Data mining is the discovery of useful, possibly unexpected patterns in data. So in most of the cases, the patterns which we find are unexpected, because if we know the pattern, then it can be easily, mapped in Excel. Why use such specialized techniques to find out things? So we do it to find out patterns which a normal human being is going to miss. If I sit in front of the data to find out different patterns, I might miss a lot of things, but a computer is going to be much more precise and apt with respect to the discovery of those patterns. Data mining is non-trivial extraction of implicit, previously unknown, and potentially useful information from data. I will come to this by the end of the lecture, then we will be able to understand it better. So what happens is you have input and you have output, right? So on one side you will be having your x axis, on one side you will be having your y axis. In most of the cases you are going to have multiple inputs. It will not be just one field. You are not going to map x to y. But normally in the primitive terms, if we want to understand, you are going to say that for x, how are you going to find out y, right? and a data set will be given to you, through which, through the data set, you can learn the possible mapping from x to y. What is the mapping between these two variables? So this is the data set which is given, and the question asked is, if the value of x is 10, then what will be the value of y, right? So the computer, the model which you are going to use for mining, that model is going to find out these associations कि x y से connect कैसे हो रहा है, right? What is the mapping between these two variables? What is the connection? Depending upon that connection, a prediction will be made to find out this value, right? In some cases that prediction can be totally exact, ditto value. In some cases there are errors. If there are errors, then we need to rework on our model and make it better. So that is the whole process. You give input, you apply some model, you apply some technique to find out the output, right? And if the output is not right, then you rework on your model until you get the results which you want. So normally, like, if you try to understand it, I am again the owner of Walmart, and I have data from the past 10 years. So I know the association between particular products, right? I have that data. That data will be used to generate a model, and that model will be using that previous data over and over ताकि उसकी predictions apt हो सकें. It will rework on itself. Once that model is perfect, then we will use that model to make predictions for future. फिर हम छोटे छोटे, for example यहाँ पे x जो parameter है, maybe there can be one parameter but there can be multiple parameters. Once our model is ready, then we tweak those parameters depending upon your questions. जो भी आपको पूछना है उसके according you change those parameters and you see the result in y, right? But in primitive terms, at the end of it, what we are doing is we are finding relationship between x and y, right? It can get as complicated as we want, or it can be as simple as this. So for example, if you talk about the housing data, this is a very classic example, also a very commonly used example in machine learning as well. You have two attributes. You have the per square feet price, per square feet area, and the price. Only two parameters, but there can be more parameters. Maybe in a city I am using a matrix for not a matrix. I am using a parameter which starts from 1 and ranges till 10, 1 to 10, and I rate the areas according to their importance, according to their facilities. Or maybe what I do, I associate a particular value with schools, hospitals, malls, those facilitation services which are going to make a housing society expensive, right? If there is a society which has all of these facilities, then obviously the price is going to go up. And if there is a location which has very limited type of services, then the price will be low. So instead of just having these two parameters, per square feet and price, you can have like 5 more parameters. Are schools available? Are hospitals available? What is the story size? Is it a independent flat type of a thing, or a mansion, or a combined home, or a hostel? The parameters can increase as many as you want. And depending upon the past sales, what was the price of a particular house, we will be having that data. Using that price, we can predict the rate of upcoming houses. If I want to sell a house from at this location where I'm living, right? So what I'm going to do, I'm going to find out the rate of the neighboring houses, right? What is the per square feet price? What is the area? And using that, I can predict a value ki estimated, it will be so and so. So those estimations can be made, and that is where this entire dimension comes into picture. You must have learnt about this equation y is equal to mx plus c, and this can be in primitive terms again, because when you technically implement a model, it gets really complex. It is not as simple as y is equal to mx plus c, but primitively we are just doing this. We are finding the connection between x and y, and given a particular x, given particular input variables, we try to find what is the output, what is the y value. So with regard to this equation, we try to find out the algorithm, we draft a program, whatever formulas or whatever functions are used, we integrate it together to find out the answer to this y. And our input, it can be single input, univariate input, which is not varying. It can be multivariate input, you can have different parameters. It totally depends on the type of data which you have. And in all the machine learning based projects or models, whatever you will be learning, always remember that y will be your dependent variable and x will be your independent variable, because x can take any value, it is independent on its own. Using this independent variable, we try to predict our dependent variable, we try to predict what is the value of y. So this independent variable x is used to find out the value of this variable which is dependent. And normally, if you come to this example, these parameters which we are using, the name of the columns, they are called as labels, or you can call them features, or you can call them parameters. The name of the column heads, like if I am accumulating the data of all the students in the university, there will be name of the columns, name, email ID, contact number, age, weight, or whatever, 10th marks, 12th marks. So those headings are called as labels or parameters, right? And using those labels and parameters, we try to generate a model. Once a model is generated, what we are going to do, we will just give chunks of data. We will say कि हाँ, name, contact number, direct, आपको specify करने की ज़रूरत नहीं है. The labels must not be specified. The model will automatically take that input and segregate it on its own. It will classify it, because now the model knows how does an email address look like, where I am going to map the phone number of a particular student. And same goes for this case also, for the housing data price case. If you give the model input, it is going to cross validate with respect to the previous data and predict whatever you want it to find out. That depends on the algorithm and the technique which is being used. So whenever we are designing a model, we have training data, which is our historic data, right? So in your historic data, you will know which particular customer at Walmart, spent how much money over a period of 5 years, what he or she bought, and how frequently he or she bought. All of that data will be available, and depending upon that, you can predict. So you're going to give your model the test data. That test data is going to give you some input or some output, which can then be checked with your training data. If your output is very vast error is there, then you have to rework on your model, right? So you will be having your training data, which is historic data, and more if we have lots and lots of data, then it is much better to train the model, because the model will be that much better, right? With the limited set of data, there will be increased chances of error. And test data is then used to check if our model is working or not, right? Whether the values returned are feasible, are working correct or not, that is used as testing data. When we implement our model on test data, we are going to get either, we will have predicted output and we will have actual output. So actual output can be seen from the test data, and predicted output is generated by our model. If there is a lot of difference between these two, then our model is not correct. We have to rework on it. And that is why the job of data scientist is typical. They need to work on a particular model for a longer period of time, because that model has to be trained, that model has to be specialized, and there's a lot of mathematical work which goes into perfection of that model, so that the model is completely capable to predict any type of to predict any answer to any question which is being subjected to it. Yes, so you have input data, right? You can call it input data, you can call it training data, you can call it historic data. So this is the big data which we have of past 10 years or 20 years, or maybe if we talk about social media, it can be for the past 2 months also. So this data is fed to the model, and under this model here, y is equal to mx plus c, that is a very basic equation. Over this model, we use the techniques, we use algorithms, we find out the parameters. Over here there will be features, those features will be used, and statistics will be applied, mathematical equations will be applied to generate a model which takes in all of this input and gives you some output, right? And that output will be checked. If it is right, then okay. If it is not right, then the model will be reworked upon. and training will again happen. So this process goes on until we have a good model. Once we have this model ready, then we apply the model on your testing data to find out if it works properly or not. If it doesn't, then again you have to work on the training of your model. So formally, the input, the x axis, the x variables, they are called as features in the technical jargon. They can be called as parameters also, labels also, but technically we call them as features. And the output which you want to find out, it can be called as a target, label, or class. That depends on the use case you are implementing. Do you want to classify your data? Do you want to label your data? Do you want to find out the target value? It all depends on that. And coming to labeled training data, when we are putting this input data, right? So if we have labels associated with it, if you have mentioned the name of the columns, then we call it as labeled training data. If the name of the columns are not mentioned and we leave it to the model to find it on its own, that the model should be able to find out कि कौन सी क्लास के अंदर कैसा डेटा आ रहा है, then we call it as unlabeled training data. So mostly we use labeled training data which has labels, so that it gets easier to train the model, right? And now let's come to this definition of data mining. It is the non-trivial extraction of implicit, previously unknown, and potentially useful information from data. Non-trivial as a word, it really means that we are trying to find something very small but significant in nature. So when we are manually doing it, when we are manually analyzing the data, we might miss some hidden associations, some deeper associations. But when we are technically mining the data, we are going to find these non-trivial things which might seem small, but they are significant to determine how any particular event is going to take shape. So we non-trivial extraction of implicit. Implicit means inherent in a way. So whatever information that is present, that is inherent in the data, but we are not able to take it out. So by using data mining, you are able to take it out, that inherent value which is of use. Previously unknown. Data mining techniques are going to give you new information all the time, right? And potentially useful information from data. So that is our data mining definition. We are trying to find out non-trivial data. We're trying to find it out from the we are trying to find out potentially useful information, the information which might be of help, right? And things which are unknown to us in the first place. So by using data mining process, data mining operations, we can find it out. We can find those connections, how dependent things are, what can lead to which particular event. All of that knowledge can be taken out. And now with the introduction of big data, so much of data mining has become even more important to find out different things. So there is a lot of scope for this also. So in the next lecture, we are going to talk about the steps in building this application, right? And after that, we will learn about supervised and unsupervised learning, just a very brief introduction, and possibly close this unit. Okay, thank you.